Good afternoon, students. How are you doing today?
Good afternoon, sir.
Thanks. Usual. What about the others?
Good, sir. You.
Hi, Kylo. It's been a while that I haven't seen you, Kylo. I know for sure you weren't at the last class.
Yes, sir.
Say it again.
Yeah. Here, sir. Having a bit. Was not last class, sir, because the internet was unstable. So I had to use servers.
The internet was unstable and what?
Internet was being unstable, so I have to use servers.
Oh, okay, you have to use that service, the data. Okay. All right, never mind. Understood. All right. Hmm. How was the day been? How was the week been? Okay. Have you guys been able to maybe look through or well, how's the reading going? Let me just ask it that way.
Sir, for the fracturing and folding, that's about the same. I just did half of it, I think.
For the what? The factoring? What is it? I didn't get that.
Fracturing, like in the rocks.
Oh, fracturing. Okay. So you started reading what it is that I sent.
Yes, sir.
Very nice. Very nice. That is a spirit. That is a spirit. That is a spirit. All right. Let me see. There are 6 of us, half the class. We need to start. We need to start. All right. Today is going to be a what do I say? Normally when you go into these exams, they'll ask you write brief notes giving examples of fracturing or fracture, fold and fault and dip and strike, and it says brief notes. So it don't mean that we have to get into a page and a half. Sometimes what they will give you is maybe about 5 or 6, or no, about 5, 4 or 5 of these small notes. And if it's a 20 marker, if you get, of course, 5 of them, it's 4 marks each. So it gives you brief notes. So you're going to write about what it is, and then you're going to have to draw, an example of what it is that you're talking about. So if you're talking about a fault or a fold or a dip or a strike, or whichever dip, whichever strike, fault, etc., etc. So you need to give like a definition of what it is, and of course you support that with an example. I'm just saying to you, sometimes they do that. So these areas are areas where we're going to be explaining. So it is that you can be able to. One of the things that I'm doing for one of your individual pieces, as a matter of fact, I worked on 2 things for you today: a group presentation and an individual piece. and I'm giving the class, the whole class, a group presentation, and each they are going to be having, I think, three different groups or whatever it is, and I'm going to collect one major project from the class. But guess what? One major project from the class, but in that major project, I'm going to have groups, different subsets, making presentations. So you can have one project where one group or one individual gets 65, one get 55, one get 50 in the same group, because you're going to be presenting, you're going to be doing your stuff. Each member of the group will be presenting, has to present. So I don't want no one person manipulating the slides and think that is going to be your contribution. And there are other criteria that I'm going to be using in order to give you a final grade. So I want one project, and that project I can tell is going to be on energy. One project. So that may carry about 20% of your final grade. There's another piece that I'm going to give you that I'm going to ask you to look at the diagram and write about its geological past. But before I give you that, I have to go through today's lesson. So it is that you can understand what it is. So it is that you are able to identify what is going to be required of you. And then you're going to be given another individual piece. So you're going to give it two individual pieces and a group piece. And that is going to account for your 50% of your coursework. So I'm saying this to say to you, the ball is in your court, you know. The ball is in your court. You're going to have about 30% of the coursework pieces as individual and 20% as a group. Now hear me out. Whether or not you want to be lazy in your group, don't believe that you're going to be beneficiary of somebody else's grade, because I have devised a plan where each person is going to be judged or assessed based on their own presentation skills. So you will get a grade for my rubric will give you a grade for the presentation as a group, but you also have different criteria for which you are going to be graded. Your diction, how you present the stuff, if you are just reading versus explaining as you go along, just different presentation style. And I will give you more information when I have it, but I want to read through it again. So I'll tell you what it is that I'm going to be expecting. So if you just going to come and put a slide up and just read verbatim something that you get from the internet, the project will have to be submitted to me beforehand, not after the presentation. It will have to be submitted to me beforehand, either a week before or 2 weeks, no, not 2 weeks, a week before or 2 days before, whatever the situation is, so that I can familiarize myself with the stuff, etc., etc. So that is that 20%. Of course, I said I'm going to give you something to describe the geological past of a section of the earth, and I'm going to give you an individual piece. The individual piece I have not come up with yet, but the other two pieces I've come up with. And then your other 50% will be your final exam. It's going to be an online exam as far as I understand it, and I'm going to ask that I will speak to you about what is going to be expected of you Cutting and pasting from the internet is not what I'm interested in. If I see that happens, you're going to fail. I want you to be able to internalize. I want to be able to explain to me what it is that you have understood from what it is that is given. All right. So all of those will be part of your assessment. So what I've thought about is that I'm not going to give you a written piece of coursework. I'll rather give you projects and individual pieces. All right. So you're seeing my screen. I think that's enough explanation as to what is required of you. The recordings are always posted, so you can refer to those. What I also try to do is to present the articles or handouts to you before class, so that to give you an opportunity, should you find the time to read and prepare ahead of time, when I'm going through, at least you will have what I've read through before and get some better understanding during my explanation. All right. I will always remind you again, as I have been doing from day one, how important it is to read. All right. It's very important. Very, very important. So looking at folding. So importantly, they are saying that when a body of rock, especially the sedimentary one, is squeezed, very important, it is squeezed from the side. Squeezed from the side by tectonic forces, and we know what these tectonic forces are. We looked at them last class. It is likely to fracture or to become faulted if it is cold and brittle. Fractured or becomes faulted if it is cold and brittle. On the other hand, it becomes folded if it is warm enough to behave like a plastic. It becomes folded if it is warm enough, behaving like a plastic. It is going to be faulted or fractured if it is cold and brittle. Folded, on the other hand, if it is plastic in nature. All right. So plastic, go back to the structure of the earth. There's a section there that has a plasticky nature to it. So fault, fold, fracture. 3 F's. Fault, fold, fracture. When does folding take place? If it is that you have plate tectonics taking place and you have it being squeezed from the side, if it is warm enough and behave in a plastic manner, you're going to be having folding. If it is cold, if it is brittle, when it is squeezed by some tectonic activity, it is going to fracture or become faulted. You know, I like to give examples. You know, I like to relate all of what we're doing into the real world stuff. Today, Mikey posted something in the group that I know everybody should see. And I said to him, what you need to do, make sure you wash it. Because old time people say, when you have your Christmas plate and your Easter plate, you only take out them plate when you have passing knock on your yard. Christmas time, take them out only for special occasion. Them say, if you don't use it, and then you take it out to use it after a while. When you start washing it, it'll go break. All right, hold it right there. So I want anybody, if you're at home, to maybe go into the kitchen and find you a white piece of what old time people call it crockery. Right? It could be a dinner plate, it could be a serving plate, it could be a cup, but something that is almost old. And if you don't have it, you don't have to do it now. But the point is, when you look at it, sometimes you see it having some sort of fracture looking sort of streak presentation in it. Anybody can relate?
Yes, sir.
Real talk. Real talk. If I remember after this class, I'll go for one of mine. Very nice stuff. Was given to me by, was willed to me, live will. Person still alive. It was a live will. Very nice serving plate. Tray. A long time I don't wash it. I tell Michael say must wash it something. A long time I don't wash it. I need to take it out today and wash it and then take a picture. It's when I look at the stuff, I was like, oh my goodness, something go wrong with it. But when I rub my hand over it, it is as solid can be. But this happens to it after time, after age, and it especially don't wash it as if you're using it. This is what is going to happen. That is an example of a fracture or a fault. That's an example of a fracture or a fault. Now we're going to distinguish between a fracture and a fault, you know. But I'm just trying to explain to you the difference between a fracture and a fault, or what a fracture and a fault looks like. The fold now, on the other hand, is if you have a plastic cup and every day you drink a hot tea out of it. Certain tea can be cold. Yeah, kind of redundant, don't. But every day you drink a tea out of it. And one day you throw the hot water in the cup. And you see the cup sort of melt downish and have curvy thing. Anybody can relate to that? Curvy look to it?
Yes, sir.
That are the fold. So at this point in time, you know, none of you should have a difficulty identifying a fracture, a fault, or a fold. The fold takes place when you have that sort of plastic matter. When something is cold or brittle, fracture. Another example is you set one ice, some water. Oh Lord, I'm speaking in reverse tone. How people set ice. You know, sometimes this is how we talk, you know. Put on some hot water for me. Anybody ever said that yet? Be honest with yourself. Be honest with yourself. Let me see how honest you are. Who ever said put on?
Turn on the kettle.
No, sir. Put on some water.
Benika, you see, because Asia not talk the truth. Benika, you never ever say, go put on some hot water for me, or never put on some hot water. Talk the truth.
I thought that for me to make some tea.
See me so. Asia, you never said that yet?
I mean, did I say yes, Mary?
Because I'm going to be an honest person. Janelle, you don't talk in my class, so you answer me. You ever talk about put on hot water yet? To make tea?
Yes, sir.
Kylo, what you say? You say no? Or you say go put on hot water?
Put on hot water, sir.
Say it again?
So go put on hot water, sir.
Yeah, the internet really go bad. I don't hear it, but never mind. Pause, what you say?
Sir, it's me. Did I say put on the kettle? That's what I say, sir.
That's what you say. You say put on the curriculum.
Yes, sir.
Okay. Then suppose you don't have the kettle, pause.
Sir,
Then
let's put on the hot water.
you say put on the hot water, don't.
No,
What you say, pause?
just put on the water or put on the kettle. Make it
Pause.
boil.
Pause today on Wednesday here. We have fasting. We have fasting service after class at 7 o'clock. Here, pause.
That was it, sir.
Well, if you were to ask me, and I were to be very honest, you can put on some hot water for me, please. And then must done the statement. They say no. I want to make some tea. Okay. What else could I do with it? Well, sorry, could I be with it? But it's true. Me know a tea I go make. So it is filled with so much redundancy in it. So yeah. So we just have to be very careful with how it is that we relate to some stuff. But just remember, once you're talking about fold, it is going to take place in that sort of plasticky sort of environment. And then we're talking about the fault, the fracture is something brittle. So this is a point I'm or maybe my internet is gone because nobody's responding.
Sir, you chip out just a while ago, sir.
Yeah, that's what I was just saying. That maybe that my internet chip out. So talk to me. Anybody ever say you can set some ice for me, please?
No time, sir. No time.
Well, what was that, Asia?
Of course.
No time, sir.
I love it. I love your honesty, guys. Yes, man. To this very day. You know, set some ice. No, why the heck you're gonna set the ice if you already have the ice? You understand? But I just saw we talk. It's just, I mean, in our culture, we just have a serious. There's a point I'm coming at you now, but I'm just gonna ride this a little bit more. In our culture, this is how we talk. Me got to good miracle. Good miracle, you know. Good miracle. This is not United States of Clarendon. This is United States of America. I go to the people them store and I don't see no trolley. I mean, say, do you have any trolley? Huh? Do you have any trolley? I'm sorry, I don't understand. You're speaking too fast. And then I pull off a Chris Rock. Do you have any trolley? I'm sorry, sir, I don't understand. And then somebody passed me and said, he means if you have a cart. Oh, a cart! So we say Rockstone and a trolley. Because in Jamaica we call it trolley. Who call it cart in Jamaica? Be honest now.
Arna.
Oh, sir, you know it as trolley.
A trolley. A trolley, we know it as. You go supermarket to say, Bridge, where the trolley them there, you know, say the trolley them run out. But in America, say it again.
Food bin.
So I have to remember now when I do travel that there's going to be a transitional state or phase in how I speak, because we can't go to the people in good store and ask them for trolley. They don't have a clue me talk about. Not a clue, right? So I have to speak about a cart. And if I ask for a cart, I said, do you have any more carts? And they'll say, oh, no, sir, we ran out. You can just wait. Somebody will soon get it. I say, okay, fine, thanks, I'll wait. You can't go ask for trolley because they don't know me talk about. Unless it's a Jamaican. Unless it's a Jamaican, I'm going to say, yeah, man, we're one of them, man. And if the Jamaicans are there, let me tell you what the Jamaicans are saying. Yeah, man, hold on. Somebody soon come and carry a cart and give you. You know, like somebody's calling a word, for example, nomenclature. It says a nomenclature and geometry, this word is nomenclature. And nomenclature means the naming of. All right? So I speak about the nomenclature of organic compounds is the naming of organic compounds. The nomenclature of geological structures will be the naming of geological structures. So what you call geological structures? Fault, fold, fracture, right? So if we call the word nomenclature and say Asia, call it nomenclature. When I'm speaking to Asia now, I can try to correct Asia by not saying nomenclature, but in the sentence I say, no man, when you're talking about the nomenclature of the stuff, and hopefully Asia will say, oh, and a nomenclature, and then hopefully she will say the right thing. Anybody ever do that yet before, or anybody ever hear somebody do that to them before?
Oh, yes, sir.
Yeah, man. Enough time. I would say something, and then me hear the person say it back, and me say, oh, I saw them call it. Me say, all right. And especially when I go overseas, because you know they have an emphasis on like data. We call it data because the first vowel we put the emphasis on it, but they put it on the other vowel. So instead of we saying data, data, because we stretch out the a, they call it data because their first vowel is short, our first vowel is long. All right, so they call it data, but we call it data. So if I'm there and I'm going to, get stuff, because I know how they speak, I will say, do you have any data? But we call it data. True or false? A data we call it, don't?
Yes, sir.
Yes,
They
sir.
said data.
You don't say that. Same way, so right. So and then if you call it data, we know say we have a different word for data. Talk truth. Yo, data, you look nice, you know. You see what I'm saying? So now we are putting that word to mean a female. So we have to be able to make that sort of transition. Now, the point I'm making, I was just riding that point a little bit. The point I'm making is, as I speak about cold and brittle, when you set, I was about to say when you set ice, but when you set water, say for example in an ice cream dish, the quart dish, and you're trying to remove it, it's well frozen, and you put it under the pipe. Tell me what you hear.
Crackling.
And what happened?
It break or fracture.
It fractures. Very good. It fractures. All right. Write it, students. You can't come to my class, and leave my class with an iffy understanding, because what I'm trying to do is to use real life situation that I know you know, so you can have an understanding. So every time you're reading, it is etched in your mind. Work with me. I'm writing this one again. So yes, you set your ice in a quart dish, well frozen. You try rock it to the left and rock it to the right. See it? Side by side. So you squeeze it from the side by side. So this is a tectonic force now you apply to the something, And you squeeze it side by side. But you turn on the pipe now, and you hear it go crackle, 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 and then you see it fracture. But tell me sometimes what happens. Hello,
Piece break.
And the line that it breaks off is known as a fault. A fault. Yes, man. Real talk. Easy 1, 2, 3. Because sometimes when I'm putting when I run the water from the bottom, and I hear crackle, and I look and I see it, by the time now I put more pressure or squeeze it from side to side. That's what the tectonic force we're talking about. By the time the ice gets out of the container, the ice crack up in a two, burst in a two. Talk truth.
Yes, sir.
Without even me using an ice pick or something to break the ice. Talk truth.
Yeah, my ice tough. My one come out in one piece.
Your fridge good. All right. Maybe me I use curse in the fridge. That's why. But what happens though? And when that happens, or even Asia, even if your ice come out and you use an ice pick and you jam it in the middle of the ice and it breaks exactly in two, don't you can put it back together and you can see the formation of the container that they had the water in?
Yes, sir.
You see that line there, so that you can see when you put it down. That is your fracture. It runs right through the structure. That is your fracture. All right, let me ask a question. Everybody understand, even at a surface level, what a fracture, a fault, and a fold kind of look like now? From our kitchen alone.
Yes, sir.
Yes,
Yes,
sir.
sir.
Better understanding.
Man, go. Say it again, Paz.
Now say yes, a better understanding.
Yeah, man, yeah. And guess what happened now? You see, sometimes a fracture in the and I was saying to you that because it is cold and brittle. So you see, sometimes that fracture in the ice, after a while, those fractures can become faults. It can go right through. Sometimes it can go right through the stuff. Right? But you know what a fracture is, you know what a fault is based on the demonstration in the kitchen, and everybody would have an idea. It don't have to be a big stuff. It could be something from your ice cube, the ice tray rather. When you rock it from side to side and you twist up the ice tray, case in point, we went and bought some ice trays the other day, 2 in particular pair. And I say, hey, this is nice. I mean, yeah, when the ice forms, it's supposed to feel nice in the mouth. I'm going to buy it. And set the ice. And when you take your ice out of the ice tray, you rock it from side to side. You twist it in opposite direction. One end you twist to the right, the other end you twist to the left.
Yes, sir.
That is my tectonic force that I'm applying to the stuff. Rockstone, you saw me twist one to the right and one to the left. The ice tray left me in two. Left me in two. So me say, okay, fine. It don't even make sense. I just turn the ice tray down, wait until it melted, and throw that ice tray. I said, all right, me get catch with one. Me don't want to get blamed. Say, it's me brought the 2 new ice tray. So me leave the other one. Our secret, don't talk it, Me leave the other one in the fridge. So when my wife went into the fridge and she was taking the ice out of the tray, that one broke on with her. So me said to myself, oh dear, you bought the ice tray. And then she says, yes, similar to how you brought the other one. I said, praise Jesus. So one a piece. You understand? Because I know if I brought both of them, you're going to say, yeah, man, you see, destructive much. You're going to brought the 2 of them. Maybe I have to leave something for she to break. Right? So we can get even. Anybody can identify with that?
Yes, sir.
All right, come. Let's go now.
I'm thinking about something else, like for example, like the pipe outside. Over time with the excessive heat, it probably get crystallized and break.
Yeah. True. But I'm going to tell you something though. I'm going to tell you something, and it's something. This is what I learned. This is Venica, right?
Yes, sir.
Yeah. I'm not looking at my stuff, but I'm catching on to the voices. So that is true, Venica. So after a while, the PVC pipes they crystallize, and sometimes you see the little fracture in them. But what is true, and I learned this the other day. What is true is that you see, once you have water running through those pipes, it will not fracture. Sorry, it will not have that fault where it breaks, or it will not be folded. You'll see the fracture, so to speak, but because you have water running through it. Now, if there's no water running through it and it becomes truly crystallized, then it's going to break through. But yes, that's a very good observation. It does happen also. Yeah, man. All right. So the nomenclature and geometry. Blow geometry, sir. Geometry. Geometry in a geology? Geometry and a maths, sir. I mean, I do geometry in maths, yeah, but what is geometry? Geometry is only talking about shapes, talk truth.
Yes, sir.
Yeah, man. All right, let me just pause and I'll say something to you. So I really want you guys to answer me because I don't know if my internet goes sometimes and I'm talking to myself, but I also want to ensure that you are engaged. All right, so I'm always hearing either Mikey responding, Benika responding, I hear Paz responding, I hear Asia responding. The rest of them, if me not call or no don't respond. Me talking on. Alexia, Kylo, Janelle, Davia, if I don't call Uno by name, Uno not unmute for talk to me. Dangerous much, but that's all I'm going to say. The nomenclature and geometry of folds are summarized right down here. So, an upward fold is called an anticline. Woo! See it here, so? Upwards. Anticline. Anticline? Why anti? But it's an anticline. So once it falls upwards, it's an anticline. But sorry, it have a different word in front of it. We're no business. We're no business with the word in front of it. Symmetrical, asymmetrical, overturn. We're no business with that. Once the fold comes up this way, remember now, you need to understand everything I'm talking about here, because I'm going to give you a structure, and in that structure you're going to talk to me about its geological past. So you can tell me whether or not you see an anticline, but you can't just say, oh, an anticline is seen. You have to tell me which of the anticline. Is it symmetrical? Is it asymmetrical? Or is it overturned? Right? So I'm going to give you a structure that we have enough something in there, and you have to be able to identify those. And that is going to be an assessment piece for you, one of the coursework pieces. It would have been a lab for me, but I'm going to give you the online lab, so to speak. All right? So you have to understand these little stuff that I'm talking about, and which is why I'm painfully going through these examples so that you can catch it. So an anticline, once it folds upwards, it's called an anticline, while the one that folds downwards is called a syncline. But it's supposed to be easy. Syncline, that means it sink. See it here, so? Syncline. Syncline. And don't necessarily have another syncline. All right? So syncline. So if you want, sometimes we talk about peak and trough, mountain and valley. This is my syncline. This is my anticline. All right? Now, it says, in many areas, it's common to find a series of anticlines and synclines, although some sequences of rocks are folded into a single anticline or syncline. A plane drawn through the crest of a fold in a series of beds is called the axial plane of the fold. Watch here. See the axial plane here, so? The axial plane is like you do in mathematics, and we're talking about the axis of symmetry. The axial plane is where we have the maximum point of that anticline, going right through all the maximum points of all the anticlines in it. So you have an anticline here, so the other piece of anticline right here, so see the other one within the different structure of the exposure. That's the word I'm looking for. All right, the rock exposure, right? So this is my axial plane. Now look at this again. This is going to be my axial plane. So it is running through almost like the axis of symmetry. Look, this is my axial plane. Why you call it the axis of symmetry? It is, and sometimes it is not. Remember, I keep saying to you that when I'm quoting the temperature of something and I say 400 degrees centigrade, if you go somewhere and you read it and you get 500 degrees centigrade, don't think that you are wrong, because it falls within the range. So if you look at this axial plane, don't this piece here, hopefully you can see my cursor. This piece of the axial plane here, so, and this piece, if I were to fold it along the axial plane, do you think that this piece out here will kiss this piece exactly?
Yes, sir.
Yeah, man. And a piece over here, so right here, so if you fold it along this piece here, so and you bend it over here, so this piece will almost kiss this piece exactly. But sir, when I look at this middle piece and I fold this don't kiss it exactly. Okay, that's fine. Sometimes I just don't like to kiss. They like to troops. All right? So that's fine. But this is going to be your axial plane. So remember, a really the things we talked about a while ago, you know. So you know your anticlines, you know your syncline, you know your axial plane. All right? So it says an anticline or syncline is described as symmetry. Go ahead, Mikey.
All right. So I know that you're not looking at the asymmetrical anticline, the names before the anticline.
Mm-hmm.
But if I was supposed to connect the dot, I would have connected it more to the left than where it was.
Absolutely.
No.
You know why? Because this is symmetrical, don't it?
Yeah.
Right. So because it's symmetrical, it means say what is on the left hand side is almost equal to what is on the right hand side. So do me a favor.
Right.
Right. So do me a favor. So that's I was going to go there, but since you got there before me, no problem. Do me a favor. Just like I gave you something to do last time. Remember, no. This thing is almost abstract because I'm not in front of you, but you must have an understanding as what it is that we're doing. Do me a favor. I want you to connect the ridges on your fingers. Little finger, ring finger, you know what they call ridges? Them little line there. Connect all of them. I want everybody to do it. Please and thanks. Connect all of them, little finger, ring finger, middle finger, index finger, and your thumb. So what I'm asking you to do is to put one palm of your hand to face the other palm. All right? Work with me. Then what I want you to do now, I want you to open both palms where the two pinky winky fingers, your two little fingers, are still kissing each other to the side this time now, not front kiss, no, side kiss. Slightly separate your hands, just slightly separate it. You can barely see the gap between your hands. Does it look like a line?
Yes, sir.
That's your axis, that's your symmetry. Right. So that will be your axis of symmetry. Not symmetry, no. Symmetry is where you put on dead people. All right? So that will be your axis of symmetry. Symmetry. That will be your axis of symmetry. Now, if you were, so what can happen now is if you put back your palms together again now for me. And I want you to put your hands out in front of you, where the back of one hand is to your face and the back of the other hand is in the opposite direction. And I want you to spread your fingers apart. And I want you to look and be very creative in this. Can you, and if your finger them don't big like Asia one, I don't know why I keep troubling Asia, you know, but if your fingers them don't big like Asia one, you should see only one set of fingers, which is the one on the hand that is facing you. Talk truth.
Yes, sir.
Yeah, Asia, don't answer because you know you can see your other hand, Asia, with your big fingers. Asia, you're supposed to glad when I finish teaching, man. You said, geez, and the teacher could have texted for me. Right. But yes, Asia. And then now, so what happens is one is the image of the other. One is the image of the other. So it sits perfectly. That's what we call symmetry. That's what we call symmetry. So yes, Mikey, I'm coming there. All right. So let's continue. Thanks, guys. You can put on your hand now. Although we know one or two, we never did do it, but never mind. You're a loss. So an anticline or syncline is described as symmetrical if the angles between each limb, watch you know. You see the piece out here, so? Limb. Then call one side of it, of the axial plane, the limb. The limb to the left, the limb to the right. And each of them have a limb to the left and limb to the right. It says if the angles between each of the limb of the axial plane and the axial plane are generally similar. So it is symmetrical if the angle that is formed or angles formed between each limb is similar. Yeah, if the angles formed are similar, they're going to be symmetrical. It means that one half is exactly the same as the other half. It says, and asymmetrical if they are not. Let us look at the asymmetrical one now. So the angle from the axial plane this limb here, the angle here looks to me to be very wide compared to this angle. Sir, it's not equal. And you don't have to take a geometry set and measure it. You can eye it. And trust me, we Jamaicans know of the eye with stuff, because when we are cook, not even the chef them are going to use the measuring something. When you are cooking school, them show you how to use the measuring something. But the moment you step out of cooking school, you just say a pinch of this, a dash of that, 2 leaves of this, just take out some of that, and you're good to go. And when it tastes apart, you say, no man, it want more, one pinch of this. Right? That's why cooking is not consistent. So you may go somewhere and find and get a nice food today and say, yeah man, the food nice. And you go back tomorrow to buy the food and say, something missing. Right? It's not an exact science. Just like geology, it's not exact. Medicine is not exact. Lawyering is not exact. Based on what the man see the case, he may say, no, you don't have a case. But another lawyer may say, no, right here so, make you have a case. Some doctors may say, oh no, you are in perfect health. But why am I still feeling pain? Don't worry about it. It comes with age. We have a change of climate, that's why. But you go to another doctor and say, oh no, you have a curve in the spine. But the other doctor read the x-ray and never saw that. So it's not exact, right? Not exact. Okay, and that's why it's important for you to get opinions. And you notice I said opinions, all right? So now it is asymmetrical if they are not. If the axial plane is sufficiently tilted and the beds on one side have been tilted past vertical, the fold is known as overturn. So when it bend up like so, it's an overturn anticline or syncline. So you have an overturn anticline, you have an overturn limb down here, so you have an overturn syncline. Now tell me, do you now know how to explain what it is that them ask you to differentiate between or among asymmetrical anticline, a symmetrical anticline, or an overturned anticline? Would you be able to do that?
I think I can
Sorry,
differentiate
can
between
you-
the.
Say it again, Asia.
I was saying I can differentiate between the symmetrical and the asymmetrical.
So what about the overturn?
The overturn might be a little challenging.
No man, the overturn, no. It's it is just folded, it is tilted past vertical. It has a greater tilt. A much greater tilt.
Okay, so it have an extra bump.
Yeah, it has an extra bump. Yeah. Yeah, man. Somebody was coming in to say, no, I can't recognize that voice. Who was that? Okay, so I was hearing doubles. All right. And then now it says a very tight fold in which the limbs are parallel. Hear this now. Story come to bomb. The limbs. Oh God. I keep doing this. I keep doing this. I keep this. 1 minute here, guys. I keep touching stuff on my screen, and I know how sensitive it is. All right, so a very tight fold in which the limbs are parallel or nearly parallel to one another is called an isoclinal fold. So look at this. this is going to be your axial plane. Watch for something. Can you see your axial plane right here? So going through with that line. Watch again. Watch it again. My axial plane is going right. That's my axial plane. Good. So everybody should be able to draw your axial plane. Now, what I'm saying to you, watch this line now. This line here, if I were to extend this so.
Oh, sir, you draw a line?
No, I didn't. I just have a cursor going. Yeah. So let's go again based on that question.
I'm not seeing a cursor, but I can identify it.
Very good. All right, and I don't even know. Hold on. Let me see now.
It's back on the screen now.
Okay. All right. Good. All right. So when I hover over the symbol, over the picture, it goes. So just watch me now. You see the top of the gray line? The top of the gray line? If I were to extend the top of the gray line, the bottom of this gray line right here, so watch me on this side. See the cursor here? This gray line that is right here, so the top part of it here, and the bottom of this gray line, you recognize that there's almost a straight line going across right here, so, and a straight line going across down here, so. So it almost looks parallel. It almost looks parallel. Let me tell you what normally happens. When the university is sending us out into the field, they normally send us out in pairs. Why, sir? It is strategic. Because when I see a fold, and I say that this is asymmetrical, my field partner might say to me, no, it's not asymmetrical. It is overturned. And I said, no, man, it looks asymmetrical. And they said, no, man, it's overturned. And then at that point in time, we have to now remove our device from us, from our waist, to measure the dip and the strike. Just to see exactly what is happening. And from that reading, we can definitively say, this is this or this is that. And sometimes, I remember some situations where we took pictures. By this time now, everybody had them 110 camera. Anybody remember 110 camera? Somebody said no?
What's that?
Oh my goodness. By this time, we all had, most of us had 110 camera, these very long cameras that we used to just go into the field and we just snap. And we have to make sure it flash. All right. And sometimes we can only afford the little print cartridge with 12.
Slim camera, them, sir.
It's same one. And we have to buy the roll of film that come in a little container, you snap it on it.
You have to continue, put it in there, roll it.
And you how old are you? I asked you the question that this morning. But yes, that same one. So you see when we go to the field, Mikey, sometimes we buy 2 or 3 of them. And we have to make sure we snap them and put them in plastic bag, should in case it rains, it don't mash up. And then we have to come back and go photo student or go clean something. And then take the picture and we show teacher and say, oh, this is what, and then sometimes we may say one thing, but when the lecturer looks at it, he says, oh, no, it's definitely not that. And then the lecturer is able to show us and like, oh, this is what it is. Yeah, man. Good. In this present day and age now where you have smartphones where you can take a photo and send a WhatsApp, you can get an instantaneous response, right? But those were the days. Very good days. All right. So we have an isoclinal fold, right? That's when the limbs are parallel. So we have to look at the limbs now. So the limbs are parallel, all right, or nearly parallel. So isoclinal folds that have been overturned to the extent that their limbs are nearly horizontal are called recumbent folds, right? So those where the limbs are nearly horizontal, recumbent. So something like this now, it may be almost difficult for you to differentiate an isoclinal fold from a recumbent fold. right? Because just remember, isoclinal is when it is parallel or nearly parallel. But a nearly parallel one could mean that could be a recumbent fold, depending on how you are viewing it. But it is always important, as I said before, whenever we're going out, and whenever you see archaeologists going out, you never normally see one archaeologist. Sometimes you see them work in pairs or more than two. Anybody ever say that yet when you're watching these videos of these people?
Yes, sir.
Yeah, man. So it says folds can be of any size. It is very common to have similar folds within larger folds. Similar folds within larger folds. Look at this exposure. This is folded limestone, gray limestone, and chert, which is a rust color. Chert. In Triassic Cotsino Formation rock in Quandra Island, BC, before you name it. The image is about 1 meter across. And that is also important. Your measurement, when you were taking, and I spoke to you about this before, when you were taking pictures of these stuff, you have to have something there to give you some dimensions, right? Can you see the fold? Watch me. Can you see the fold here? Can you see the syncline and the anticline?
Yes, sir.
Yes, sir.
Very good. All right. So let us focus on the anticline in the center of that fold. Would you consider this to be asymmetrical, symmetrical, or overturned?
Symmetrical.
Very good. Everybody agrees?
Sir,
Yes, sir.
Say it again.
Yes, sir.
Oh yeah. So I would. Oh no. So I would consider it as a symmetrical fold, anticline. Right? It is symmetrical because when I look at it, and this is what I'm saying to you, you can eye it. When I look at it, I'm seeing where the angle from the axial plane on this limb. Remember, we're using the jaws on now. We're not going to talk about the side. On this limb seems equal from just eyeing it to the other limb. We can clearly see the syncline here, and we can clearly see the syncline on the other one. Now the other one, the syncline for one is marked, is significantly different from the syncline in the other one. True or false?
True.
So at some point in time, one may be able to say that you will have an overturned anticline to the left or to the right. That's a question. You may end up with an overturned anticline. Is it to the left or to the right of that picture?
The water anticline?
The overturned one.
Oh, to the right.
Very good. Excellent. Because of what it looks like to me, I'm thinking that at some point in time over here, so I'm going to have an overturned anticline. So when you go into the field, you have to be able to identify the types of fold. You know there are different types, and to be able to explain what is happening. So this is what I'm going to be doing. I'm going to be giving you something similar to this, and I'll ask you to discuss the geological past. So in a discussion such as this, I could tell you that it is folded gray limestone, right? You can say, well, sir, here the plan. I'm seeing an anticline, in the center of the picture. But it's not just an anticline. It is symmetrical. The axial plane is clearly defined, and the limbs are almost equal. The angle formed between the axial plane and the limbs are almost equal. You can also say, speak about the syncline. One syncline is more pronounced than the other, and you could even extrapolate to say, and to the right of it, the anticline that is going to be formed here, based on the folding that takes place, appears to be an overturned anticline, right? So there are other descriptions and explanations that we're going to learn tonight. So by the time we're finished, we should be able to describe any block of any surface. You know, there are times I'm driving on the road to the country in particular where you have these mass exposure, and I'm looking and say, oh, whoop, very well defined folding taking place. But what is folding? What is fault? What is a fracture? It is a plate tectonic activity, right? It is a tectonic force that is going to be squeezed from the side. We know it's a fault or a fold, brittle. We know it's going to fault or fracture, brittle. We know it's a fold if we're talking about a plastic manner substance that constitutes the formation of those stuff. It says anticlines are not necessarily or even typically expressed as ridges in the terrain, nor synclines as valleys, right? It says folded rocks get eroded just like all other rocks, and the topography that results in typically controlled mostly by the resistance of different layers to erosion. All right. Now, I spoke to you about the lithosphere that is seen along the highway. Sometimes when they cut through the surface of the earth, like the mountains for argument's sake, to build roads, and you're seeing these beautiful folds, the mere fact that you have now exposed the fold to weathering, you may have water seeping inside of the syncline here that cause it to be like this. So over time, you may have a distortion of the fold that is taking place because of the weathering caused by man's activity. All right. So you may see a fold that looks one way this today. Next year, this time, we go and look at the same exposure and you see a difference. Why could this be, sir? Weathering. All right. So, you know what your syncline is your. So when you look at the topography, this is the topography of it. In an area of folded rocks that have been eroded, this is what you're going to be seeing. This is going to be my anticline. That is my syncline. My anticline, because you're going to look at the axial plane, right? So this is when you're looking at the topography of it. You know, the topography of it. All right. Everybody know what topography is?
Geomorphology.
The features.
There you go. Both of you are saying the same thing. Very good. All right. So now, they gave an exercise on here. It says this photograph shows folding in the same area of the Rocky Mountains in figure 12.1. Describe the type of fold using the appropriate terms from above: symmetrical, asymmetrical, isocline, overturned, recumbent. You might find it useful to first sketch the axial planes. You know, so this man is not, you say, sir, they normally travel in pairs. You know, the man is not travel alone, talk truth. Or you know, say him alone not travel.
Cameraman.
All right, very good, because you have somebody that take the camera. I mean, the picture, right? So it is supporting my point. All right, now I want you to look at this. It says it's first. Okay, so normally what happens? So when we normally take the photographs in the and incidentally, one of the areas that I thought I was going to make a living from is aerial photography. I honestly enjoyed.
I love it.
Aerial photography. Oh my goodness. I mean,
Beautiful.
oh, Mikey, I could, if you gave me an aerial photograph, I was able to plot the mountains, the rivers, the streams. I could do that in a jiffy. And I don't know, to be honest with you, I think it just came natural. And I thought I was going to make a living out of aerial photography. Kill me dead. When I finished, I was going to become an aerial photographer. But I recognize that there's no real money in it but it's just very nice.
Absolutely none.
Eh?
Absolutely no money.
Trust me. So it just shattered my dreams, and I said, okay, fine, find something else. And look at me, teacher. Can you imagine? Oh my God. But anyway, let's go. So what I normally do when I take these photographs, we normally have, these markers that we'll carefully look at them, and we always have to have colored markers. So every time you look into my bag at school, I have colored permanent markers. And guess what? I don't want the big tip one. I want the very fine tip, maybe like the 0.1. The 0.5 may be a little bit too thick for me. And I will just go and just buy these markers and I always have my geometry set. Why? Because I'm able now to plot the axial plane. All right, I see one. Can you see the cursor on the thing? Talk to me.
The one right above the head of the gentleman.
Very good. So where the gentleman is, there is an axial plane. You see that big? Oh goodness gracious. Why can't I? All right. So look at me now. Work with me. So where you see the gentleman down there? To the left of the gentleman, you're going to see two dark spots. Not two dark spots, two dark lines looking sort of thing.
Yes, sir.
Right, and then over the other side, let us call the right word, the limbs. The other limb of the man, you see the little white stones inside of them. So you have two limbs over there.
Yes, sir.
Yes,
Good.
sir.
And then up top, now you have like a big boulder inside with a little one underneath it.
Yep.
My axial plane would run right through there. Very good, Mikey. Based on your description above the man, I would get an axial plane right through there. Now, would you consider that to be asymmetrical, symmetrical, or overturned?
It looks asymmetric based on the axial plane.
What say you, the rest of you?
I would say asymmetrical too, sir.
Okay.
But sir, isn't this fold a reverse?
Aha! Because guess what now? There is another thing that is coming up here, because I'm seeing something that is parallel. Look above. I don't, guys. Oh goodness. Can you see the screen now?
Yeah, it's better. It's bigger.
Much better.
Yes, sir, much better.
Thank you, Jesus. Don't ask me what I did. Father God just did that a while ago because he recognized how struggling. All right.
Completely different now.
All right. So if you look right here, so don't you see an axial? Watch your cursor. Don't you see an axial plane right here, sir?
Yeah.
No,
All right. Good. And if you look at this limb, don't this limb looks like it is parallel to this limb up here?
Yeah, that's it. Yeah.
Right. So it looks parallel to me. And then now let me just look at this thing a little bit more. Okay. So look at this axial plane. Watch your cursor to the left. There's an axial plane that goes right here, come right through, comes somewhere here, and then guess what? It comes somewhere right here, so because this piece also will form some level of an axial plane right across here, right? So I'm seeing one right there. One could also say that there's another one from the cursor to the left, to the right, I'm sorry, all the way across, and come right up here, so, and come right through here, so. It's even right over here, so where am I? Even right over here, because this axial plane will come right over here through this point right here. Can you see that?
Yes, sir.
Yes, sir. It's becoming.
Watch me again now.
Parallel.
Very good, very good, very good. Because that's the point I was going to make now. This limb, in comparison to this axial, this limb looks like it is parallel to this limb down here. So look at this limb right here. So, and then look at this limb right up here. So, don't it look parallel?
Yes, sir.
Yeah, man. Yeah, man. Yeah, man. So it is something like this I'm going to give to you that I want you to be able to go and look at the stuff. Just observe it. Let me tell you something. It's right about now. You know, funny story. When I first went into my GL10A class, that's a code for the Introduction to Geology on campus. I'm saying to myself, but this man out of order, how unprofessional. How can you be coming to a university class and dressed in sandals and a pair of shorts and t-shirt? I said, this is not it. No, when I go to chemistry class and I go to math class and I go to other classes here now, teacher dressed like teacher. But everyone, not everyone, because Prof, him was okay. Yeah, him did okay. Him was Indian, so him okay. That one did okay too. But I'm telling you, there's one lecture in two lectures in particular. Every single day is a pair of shorts, sandals, and shirt. T-shirt, that is. And I'm going to tell you, there are days, you don't have me going through the stuff with you. There are days, Prof will come to class with a lot of handouts, many copies of the same handout. And he will say, Shand, come and distribute this one, please. And my homebike just drinking him coffee. He said, read. And that's why we have to, I'm saying to you, you have to read. And he will just give you this and say, okay, look at this exposure. I want you to write an essay of all the stuff that you're seeing, because he's training us to have eyes that we can see. So when you look into this, it's a whole heap of something, because Mikey was saying, sir, I am seeing something where the man is right up here, so. Right here, so. But when you go further,
Sorry, not hearing you now.
to do it. So in the interest of time, I identify some for you. In the interest of time, I want to look at this. Hopefully for next class, I did some mapping of where we are and where I need to get to. I give you that to do. I'll have 2 more areas to look at, and we should be able to finish the syllabus and finish it on time. So come next class, we can have a little conversation on this piece here. And then now I want everybody to do it, so we can have a conversation, so people can say, no, sir, I have something different, and then we can look to see what is really happening. Look to see what, oh, so I didn't finish the story. Can anybody tell me why geologists normally wear shorts?
Why they normally wear shorts?
Mm-hmm.
Always in the mud.
Okay, all right. You know, what kind of shoes this man have on?
What sandals?
Okay.
Everybody Dr. Mark usually do that, wear sandals or top pants.
Right, and you know why? Because sometimes when you're going over into, you may go in a marshy area, you may have a puddle of water, but you see something and it connects, an exposure connects to something that you would have seen on the other side of the mountain, and you can't cut through the mountain to verify it. But if you see it on one side of the mountain, and then after that, now you make your record and you come and sit on the other side of the mountain, you can say that you've just discovered something. So chances are, this is something that is worth noting. You may have to glide across the water, and you may just have to walk in the water. Take off your shoes and socks and your sandals and socks and just go across. Important, very, very important. So that's the reason. All right. Okay, so that's one. That's one.
Sir, but that photograph, sir, it has several different. Too
many. And I'm saying, even when I reduce it and look at it like that, I can see a whole lot of stuff. Now, one of the things I was saying earlier, that's why I was talking about the markers, and it did say you might find it useful to first sketch in the axial planes, and that's why I use my markers, because when I have an aerial photograph, a photograph, or even a photograph of this nature, what you could possibly do for me, guys, is to print this. I will color black and white, it doesn't matter. Print it And then what you can do is to sketch in the axial planes. And once you sketch the axial planes in there, the things will come in even better for you. You'll be able to see it. So that's a point I was making when I spoke about having these different colored fine tip point markers. Because sometimes what I'll do, I will trace the limbs. I'll put in my axial plane. I'll trace my limbs so that it becomes a little bit more emboldened, so I can see it much better. Very important. So I'm going to give you that exercise. Listen to me. I want you to do it, you know. I want you to do it. I'm not meeting you for a physical lab. So this is going to be a lab activity. I really want you to do it. And at some point in time, I'm going to be asking people to show me a picture of them sketching in the axial plane, them sketching in the limbs, and identifying the anticline, syncline, etc., etc. And I have to name it the anticlines, which of them it is, and show me the synclines. It's very important that we, and if it is that you're seeing in the isocline or overturn or recumbent stuff in it, you know what all of those are. All right? All right. With that said, I'm going to stop share. You all have the stuff. As I said before, one of the things that I do, I don't want to surprise you. Even if you don't read through, at least look at it, and you can glance through. What am I looking at, Lord? So that you can have an idea what it is that we're doing. All these documents are in your WhatsApp. For those of you who are a little bit more interested in what it is that we're doing, can actually go ahead and do a little bit more reading and research on your own. All right? Oh my goodness, when you're having fun, time runs. Jesus. Sure. I thought I'd have been a little further than where I'm at now, but never mind. Let me share here. All right. So I'm looking at my fracturing and my faulting. Remember, fracture and fault occurs when it's cold and brittle. Talk truth. Talk to me now.
Yes, sir.
Yeah, man. And the fold occurs when it is more of a plasticky sort of material. That's why I gave you a little story at the top of the class, you know. These are things that I want you to do, because in your write-up again, you can speak about the environment or the material based on the geological structures that you're seeing. So it says a body of rock that is brittle. Here it goes again. Either because it is cold or because of its composition, or both, is likely to break rather than to fold when subjected to stress as a result of fracturing or faulting. Fracturing is common in rocks near the surface, either in volcanic rocks and have shrunk on cooling, or in other rocks that have been exposed by erosion and have expanded. Do you remember I said to you that when you look at the lithosphere going into Ocherius in particular, on the other side of me driveway here, so you will say to me, oh sir, I can't find it some other place. Because the lithosphere is now open, the structure of the earth that they cut through to build the road, because that structure of the earth is now open, you can have fracturing occurring because the rocks have been exposed by erosion and have expanded. All right? So these are things that cause it. So erosion causes all of this to happen. So sometimes when if you map a particular area, the structure geologically in a particular area, and man's activity would have disturbed it, chances are you go and look at it some other time and it differs. It differs. And then now one now has to compare what it is that you would have gotten at one point to what it is that you now have, and speak about the geological activity that would have caused the difference in its geological structure. All right. So let me see if I can bring these up. All right. So you see, you can see the fractures in all of this. Talk truth.
Yes, sir.
Don't I saw the ice look when you put the water upon it?
Mm-hmm.
Yeah, man. Same way so. Same way so. So these are fractures. Now, what it is that sir is trying to do today, I'm trying to show you how to identify your faults, your fracture, your folds. Very important. Very, very important. All right. So yeah, man, them something a fracture. Then sir, when I say one fold, no folds here. So fractures, fractures, fractures. All right. Now, I keep saying to you that I know I won't die some ways because I know I'm not going to put myself in that position to die. It's all of them rock climbers, you know. You may have somebody who not have nothing for doing this life and decide that they want to become a rock climber and decide that they're going to climb this rock and throw up them like a anchor and try to climb up. I ain't stepping on these things because this fracture, as it says, is a fracture. I mean, put my 100 pound on it, it'll go drop. It'll go broke off. And it's me sliding and lick out my teeth them out of my mouth, and chances are a concussion and me gone. You understand? What's the point? Some of these structures that you're looking at are very fragile. Why, sir? Because of the erosion. Because of the erosion. What are these white stuff? Anybody can hazard a guess?
No.
Say it again.
No.
Yes, snow. Right? Snow. So the mere fact that you're seeing here, you can say, oops, it's not a fold, because fold occurs in more plasticky sort of area. When it's brittle, it's and cold, it is going to be more of a fracture. So you know what that is. See so many hints I'm giving you? All right, let's go. A fracture in a rock is also called a joint. A fracture in a rock is also called a joint. There is no side-to-side movement of the rock on either side of the joint. No side-to-side movement. Most joints form where a body of rock is expanding because of reduced pressure. As shown in the two examples in figure 12.9, let me see if this is 12.9. Yes, in 12.9, or where the rock itself is contracting, but the body of rock remains the same size. The cooling volcanic rock in 12.4a. I don't have 12.4a. That is another page in the stuff, so we can forget about that. In all of these cases, the pressure regime is one of tension as exposed to compression. Joints can also develop where rock is being folded, because while folding typically happens during compression, there may be some parts of the fold that are in tension. So if you look at this fold, come on now. If you look at this fold, you can see these fractures inside of the fold taking place. That's what it is talking about. A depiction of joints developed in the hinge era of folded rocks. Note that in this situation, some rock types are more likely to fracture than others. All right. So yes, you have a fold. So you can have a fold, and within the fold, you are having these fractures within the fold. All right. Yeah. Finally, joints can also develop when rocks is under compression, as shown in this figure 12.11, good, where there is differential stress on the rock. And joint sets develop an angle at the compression direction. So guess what? You have compression taken from top to bottom, and you have compression taken from here to
Gone again.
Sorry, not hearing you.
where the stress, some possible stresses come from in these rocks exposure.
Sorry, you have to go back over that section. We weren't hearing you.
Oh, I'm so sorry. I don't know what is happening, but I have good internet here. I'm asking, can anybody explain? What I said to you is that joints can also develop when rock is under compression, as shown in this figure right here, where there is differential stress on the rock. You have some stress coming from the side, you have some stress coming from the top. and joint sets develop at angles to the compression directions. So I'm asking, can you give me an example of compression in your rock exposure? What do you think could be one such cause of compression?
There being a convergent plate boundary.
Say it again, Asia.
There being a convergent plate boundary.
A convergent plate boundaries? Okay, that could also happen. What if you are
What about moving, they call it now, uplifting of a particular section of the land?
okay, so you're going where I was going initially. Yeah, so if you are putting a structure, a massive structure on a piece of the land, do you think that this is going to cause compression at some point in time to the rocks?
Yes, sir.
Yes,
Over
sir.
time, it will.
Yes, sir.
Yes, sir.
Yeah. All right. Now, let me just explain to you. So the very first class I gave you some possible jobs that include geology. You see,
Mining.
very good. You don't have, you see, you know, it's not like when you go to a chemistry class or a maths class and you have enough people in another class. When you go to a geology class, you have 12 students like us here. I think we had about the same number of students doing it. And by the time we reach final year, it's about 6 or 7 of us, because some people just drop out and say, yeah, the plan, we can't go no further. So sometimes I have about 6 people don't recognize the importance of studying areas like these. But I will tell you one of the importance of it. You can become a civil engineer and you're doing construction of developments. You know, say, as a civil engineer, you have to do some levels of geology, even an introductory level of geology, know about faults and folds and them something there. Because what you have to do now as a quantity surveyor or as a civil engineer, you have to look at the rock type. And this is why sometimes they will drill down into the earth in order to get sample of what is happening there. The rock types that come up when they drill down, the rock types that come up, sometimes they drill down and put a camera down there with and of course with some lights, so they can actually see what is happening, so they can say, bedrock is good, it can take up a structure here. So some people start dig foundation and start put on 2-story house and don't know what is happening down at the bottom down there. So people do them something there now. So when heavy rains come now and there is nothing substantial to hold it and the soil becomes liquefied, the structure start move, it start to swim, because proper land surveying was not done. So a land surveyor in a Jamaica, the only industry that I saw, let me tell you something. You see, in a COVID, the amount of construction of buildings were going on is more than where I see before COVID. If you drive up and down now, because I wasn't on the road, and how I know, because you say, sir, but the Prime Minister say must stand out, so how you know that? I know now because I'm going out to say, what year? When did they let down this house? Until this thing almost finished, or it finished. And say, whoa, going on, right? It's very lucrative. And as somebody who is going through this thing here now, you can go and you can say, hey, the mineralogy is XYZ. Sometimes what the man them do, is dig down. And when them dig down, Them recognize a boy, you know, say it was a cane piece. It's like, oh no, that means the soil type down there is very loose.
Clay. Clay.
Yes, you know what the man them have to do now? Them have to go and get them either them black stones or get them gravel and get them limestone and compact the earth before any construction can do. So you see, sometimes they're doing their construction and them put the whole heap of gravel and stuff. They are compacting and them have them tractor running over it and wetting it and running over it and make it set and have to run over it. They are actually compacting the earth. So that's why in some places, in Portmore, and other places too, where they will say to you, these developments should not have multiple story. It's on a single story that they can accommodate. So the title tells you, because the soil type cannot withstand that level, that weight that we're talking about. And if you put that there, you're not only going to mean breach, but the likelihood to have some sort of collapse. What will happen now is that the weight, two things: the weight, the structure that is beneath would not have been built to hold up something atop it. So we have weakening in the structure, and there's something I call geological structures too. You know? So weakening of the structure, and then when you have the weakening of the structure, at some point in time, there's cracks in the place until it reaches that pressure point where it just gives way. So one has to be very careful and very mindful. So this is exactly what is happening, because when you put something that is, when you cause that sort of compression, it is going to form these cracks into the structure called joints. And after a while, when the pressure is being applied to it, because remember, you know, you just build a house, you're not carrying your furniture yet, you're not carrying your claw bath yet, you don't carry your washing machine and your dryer, and you don't carry all of them wonderful stuff. So the weight is going to get even heavier. And some people decide, say, here the plan. You know, I want to put on 400 gallon or 1,000 gallon water tank because I'm having water problem. And you're adding more pressure to the stuff. You have to be very careful. Ever so often, I look at my washroom just to make sure that where the water tanks are, I am not seeing any compromise, any cracks in the roof. The moment I'm seeing any crack in the roof, it means that I have to go now, empty the tanks, and go and do something there so that I can strengthen the structure, because you won't want it to cave in on you, right? So some people say, okay, fine. They will say a 1,000 gallon may work, and then when you put the 1,000 gallon, you recognize the boy, you're washing more, so the 1,000 gallon can't work. So you want another 1,000 gallon. Mistake. You put the other 1,000 gallon there, and then it starts to create problems. All right, so you have to be very careful. All right, faulting. Let me see, even if at least I can just oh Lord. All right, let me see if I can just start the faulting here. I'm going to ask you to read, so when I'm going through this again, I can go through it pretty quickly. It says a fault is a boundary between two bodies of rock along which there has been relative motion, right? Don't you worry about, as discussed, this is just a section of a book that I copied just to bring across my point on faulting. It says earthquakes don't necessarily happen on existing faults, but once an earthquake takes place, a fault will exist in the rock at that location. Some large faults, like the San Andreas Fault in California, which extends from northern BC through the central Yukon to Alaska, shows evidence of hundreds of kilometers of motion, while others show less than a millimeter. So look at this example here. It says a fault is being shown by the white line. This is a fault. This is my fault line. That's my fault line. No, sorry, I should have done this. That's my fault line. Everybody can see this? That's my fault line. Can you see the amount of displacement that took place from this fault line? Or from this fault? Yeah, man.
The red line.
Right. So the red lines, and you see this white line here, so? The white line is the distance between these two red dotted lines. So this is the amount of displacement that took place with this fault. So before the fault came into effect, hold this line right here, so red dotted line, and draw it back over to this line here, so that this red line would have extended all the way up. But there was a displacement to the right, a lateral displacement to the right. So that's where it is that you have your fault line. Now, the truth of the matter is, you can have fault lines running from one country to the next country, from one state to another state. You can have a fault line that runs from up at Axial, come right down over to wherever. Right? So, looking at it, let me ask you, what do you think are things that are happening up here, so?
Fractures.
Very good. These are fractures. So somebody may say, sorry, it's a fault. It's not a fault, it's a fracture. Right? So the weight on this rock now would have caused a fracture that is right here. Right? So those are fractures. And I can't see anything else, but I can clearly see this fault line. Clearly see this fault line that runs across, and I can see to you that there has been a displacement. See the displacement here? This much in this fault line here. All right? All right. So there are several kinds of faults, right? Several kinds of faults. And I will ask you to read through those, but there are several kinds of faults. So you have a reverse fault, where the hanging wall is going to be atop the foot wall. So this piece here is going to be called, you're going to read through all of this, and I'm just going to go through this very quickly in the next 5 minutes, right? So you're going to have the reverse fault, where the hanging wall is up top, and the foot wall is beneath. So think about it. Foot down at the bottom, and then we have the hanging wall. When you hang something, it means that it's up top. So the hanging, does that make sense to you, by the way?
Yes, sir.
Yeah, man. So the hanging wall, once I talk about the hanging wall, it's going to be up top. When you hang something, you're putting it up top, eh? And the foot wall is going to be at the bottom. So these rocks raise up relative to the rocks across the fault. So see the fault line here? Now, this piece of the arrow, and this is my reversible arrow that I have here. This piece of the arrow is showing where the, keep forgetting that I can do this. This piece of the arrow is showing where the hanging wall is. So it is going up, and then my foot wall comes down. So the compression is coming from this way, from this side, from left to right. That's where the compression comes in. Now, when the compression comes in, it means that at its weakest point, you will have some levels of movement. Bam! I have my fault line right here. Piece go up, hanging wall. Piece go down, foot wall. Look at my normal fault. Look at what happens. This is my reverse fault. My normal fault is where I have this hanging wall going down and the foot wall coming up. So this is a normal fault where you have a drop in something. The reverse fault is where you have the hanging wall up top and the foot wall on the bottom. The normal fault is where, and this is says the fault scrap. So scrap. So what is going to happen here is that this piece is going to fall downwards. So the rocks drop due to relative rocks across the fault. So when you have the rocks falling from this side and the hanging wall is going down and the foot wall is going up, you're going to have a normal fault. All right, normal fault. As opposed to this one here, this is your fault trace and this is your strike slip fault. What is the difference between this one and this one compared to this one?
strike slip fall runs along lateral.
Or horizontal, good. Very good. Same different lateral, horizontal here, and
And the reverse and normal is a vertical movement.
the vertical movement. Excellent. So you have those being vertical and this being horizontal. All right, vertical and that being horizontal. I am going to, time is of the essence. I'm gonna just show you something here. No, it's not on this drawing. All right, it's not on that drawing. I'm going to ask you to read through this document in addition to the other documents. I'm not going to have to come back to the other documents for next class, but I'm going to ask you to just continue reading through this one here. I was just trying to find. All right, let me just go and just make reference to it from here. So when I'm speaking of my dip and my strike a little later on, it depends on this piece here being pushed this way or if this piece was dragged this other way. So you have to, and this is the word, you have to observe the orientation of your fault lines, your folds, your fractures, in order to correctly name the type of fault, folds. You recognize that so far, don't it? With the asymmetrical, symmetrical, and the other one.
Yes, sir. Quick question though.
Yeah, man.
Right, so when you're actually in the field, how do you tell which is the hanging wall and which is the footwall?
What is happening here? Which one do you think here is a hanging wall and which one do you think is a footwall? Okay, let me ask you a question. What is this? What is this line right here?
That's the fault.
That's a fault line. Which piece is up here, so? The hanging, and this one is the
footwall.
Yeah, man. So you see, you can see it. So this line here is my
Fault line.
my fault line, right? And this piece here, whoa. Oh. You can see the fault line right here, so again. I can see my hanging.
Which one move up, which one move down? It's still not clear.
No, because, no, man, you can see that this. No, man, you can see that there. This one here drops on this side. I don't know if I can bring it up some more. No, man, you can remember you're going to be seeing the exposure now. So you're going to see the whole exposure in itself. So, for example, this is the whole exposure now. I'm not seeing the whole of this, but you see the whole exposure here. So in this piece here, look, this is a topography. This is a whole exposure of this rock here that you're looking at. The structure you're looking at. What is this line here that you can see?
That's a fault line.
That's a fault line. All right. What do you think happens? Which side, the left side or the right side falls?
Right side falls.
So how you asking me the question and you correctly answer this one? So when you go out in the field,
see that one here, but when you look in the books, them and them
because you're not seeing the structure. So like this one here now, it said looking down from above. I can see this and say I can say that this is a foot wall and this is a hanging wall, right? Hanging means that it stays there and this thing drops down. I can see this one clearly, but sometimes when I'm not seeing the whole structure, like this one here, I can say that this here could be the foot wall, but I can't. I'm not so certain. I'd have to go look at it one more time, but I can clearly see my fault line. My fault line is very clear. This one, my fault line is very clear, right? And the fault line comes all the way down, right? But yes, when you look at the structure, like on this side here, no Papa, you can clearly see which is a hanging and which is a foot, because you can see that, and even if you go down this side, you can see that this piece fell somewhat. And you can, and it's not a deep fall neither, because it is not as deep as
And
even this
further,
one.
further right, there's another fall in that one as well.
See it right here, sir?
Yeah.
Yeah. So you have many fault lines. I'm so happy that you can see it. Which line is this line though?
The fracture.
Fracture.
I just love this class. I love it. Here's the plan now. I will love the class even more as I take my leave of absence 2 minutes past 7. If you go and read through the rest of the documents, so that we can look at pictures and we can say, this is this. It's just like asking you, and just like what Mikey can say, sir, I'm seeing another fault line. Duh, we are all seeing it. But what is that one to the right of it? This one here. So it's a fracture. Duh, it is. Right? So this is what I want you to do. When you finish this course, you can tell anybody that I did an online course in geology, but I am able to identify fractures and faults and folds. All right? Bless up. Big up on yourself. Make sure you read. Make sure you guys are reading. I give you the handouts. I give you the handouts in soft copy. Bring it up on the phone now and read. Before you go to bed at night time, you can say your prayers. Open your eye before you drop asleep and just read it. A page at a time will make a big difference. All right? Bless your hearts. Thanks for coming out and we will talk.
All right, sir.
Yes, sir.
Yeah, you too.